right, as we wait for folks to come in the room, if you can, please scooch in your chairs to give people more room to get past you in these tight aisles. We'd appreciate it. All right, it looks like we've got most people in the room, and so as you finish taking your seats, I'll get all the administrivia out of the way. Welcome to Best Paper Session 1. I'm Maureen Holbert from Booz Allen Hamilton, your session chair, joined by Sandra Chambers from General Dynamics as the deputy session chair. As a courtesy to our presenters, please silence or turn off your cell phones. While photography is allowed, we ask that you do not use flash, and please no video recording of the session. If you need to leave before the presentation's over, please exit through the door you arrived in. And as a reminder, all conference registrants are eligible for CEUs, so please make sure your badge is scanned, if not on your way in, on your way out, so you get that credit. Our third paper today is Wires Crossed in a Digital World: How to Prevent Misalignments in Human and AI Decision-Making. Our presenter, Dr. Summer Rubensky, is a research scientist and capability lead in the Training, Learning, and Readiness Division at Aptima. She has a background focusing on human performance, cognition, and training in emerging systems. She received her BA in psychology, MS in aviation, human factors, and PhD in aviation sciences with a focus in human factors from Florida Tech. Ladies and gentlemen, please welcome Dr. Summer Rubensky.
Alrighty, thank you everyone for taking the time to attend this session. Today we're going to talk about how to prevent misalignments in human and AI decision making. I'm presenting today, but I do want to take a moment to acknowledge all of my authors that are on the screen there who contributed to this project throughout the duration of the effort. I don't think I need to speak to anyone or convince anyone about the boom of AI that's occurred over the past year. We recognize that with a data-rich environment, AI can help reduce the burden for decision makers by providing relevant information at the relevant time and allow them to be able to compare alternatives. A lot of the papers throughout this own session has also talked about the importance of trust. We talk about calibrated trust and the importance that users understand and put the correct amount of faith within those systems. When undertrust occurs, we end up finding that users believe that the system is ineffective, and they resort to more manual processes. As we're investing so many dollars into AI systems, it's important that users use the capabilities that they provide that have been demonstrated to be effective and efficient. When overtrust occurs, we see that a user believes that a system can do more than it was designed to do, and won't engage in cross-checking and validation behaviors. As some of us have seen and have played around with ChatGPT, I'm sure you've seen that sometimes it can be incorrect. So it's important that we ensure that we have a calibrated trust in these systems. For the duration of this presentation, I'm going to be referring primarily to a competency-related trust. When we talk about that, that means that you have a correct mental model of what a system or an AI is capable of doing and what it isn't capable of doing. I'm sure we all have an elderly parent that's been trying to print off a document on their printer, and they're getting frustrated at both the laptop and the printer that it just won't print the document. However, their Wi-Fi is turned off. What we see there is an incorrect violation of trust because of their mental model is faulty in how the system actually works. So what we sought out to do was to develop a web-based system that could calibrate trust and calibrate the mental model between the AI and the human. When we say that, we mean not only help the human get a better picture of what the AI is capable of doing, but also help the AI get a better picture of what the human goals are in a dynamic and naturalistic way. One example that I'll use throughout the presentation is joint all-domain command and control. For those of you that are unfamiliar, that's trying to work with all of the services, which involves a myriad of different platforms, sensors, and data types coming from multiple different services. So one of the key aspects there, shown in the middle of the graphic, will be analysis and decision making. In a completely information-saturated world, how do we present relevant information to the operator that helps them achieve their goals more effectively? For this effort, we went through a series of usability tests, design workshops, and walkthroughs. The pictures that you see over there on the right are of a previously designed system called Alfred the Butler, and that is an acronym. Don't ask me to repeat what that stands for, but it is a support tool for the intelligence analyst domain that recommends publicly available articles for users to review relative to a problem statement they're trying to answer. We utilized this tool as it allowed us to look at the factors that users consider when going through decision making in a plain text format that allowed us to control for a lot of other factors in this use case. To kick it off, we started with a cognitive walkthrough in which users went through in great detail as they were going through the recommendations that the system was providing through them, what they were thinking through, how they were making their decisions, as they interacted with it, why they were taking specific actions, so we could start to pull out some aspects that users consider in decision making that the AI system may want to take into account. What that cognitive walkthrough uncovered was 7 different factors that users consider in their decision making. The top level related to the recommendation of an article itself included the article date, article title, the source that the article was coming from, as well as the author who wrote it. But we also uncovered 3 relative factors related to their problem statement. In the intelligence domain, this is called the priority intelligence requirement, or the PIR, so if you hear me say that throughout the rest of the presentation, that is related to the problem they're trying to answer. Users also considered the relevance of the title to the PIR, as well as how many keywords were present in the title of the article related to that PIR, and the presence of keywords within the article when they reviewed it in detail. So we took these factors and then tried to uncover ways that we could build these within the systems to be able to capture which of these factors were most important to particular users. So we engaged in a design workshop in order to build in unobtrusive behavioral hooks that could be used by an AI system to understand from the system when distrust or overtrust may be occurring. First, when we talk about AI recommendations, especially when we talk about, let's say, personalized ads, there's a lot that we skip over. So we needed to build in a behavior hook that would allow us to truly understand when someone has chosen to ignore recommendations from an algorithm. So we built in a UI so that when users go to look for new articles, they have to make an active decision that I would like to see new recommendations from the system. Next, we built in the factors that I had described on the previous slide, where users could provide feedback to say which of the factors that they found either relevant or, in the case of an article that they rejected, that they found irrelevant, where users could select those different factors on that. And lastly, we looked at providing a little bit of transparency back to the human on the AI's mental model by showing them the keywords that were presented and relevant in not only the PIR, but also within the article, so that they could see the keywords that were shared, by also providing them suggestions on other keywords that they could add that were present in that article and add those to their search. What that allowed the user to do is get a better understanding of why certain recommendations were being presented to them and how they might be able to make it the recommendations more effective moving forward. Now that we have a better idea of how we might go about presenting some of those factors and providing info back to the user, we conducted our first usability test. So we wanted to see, are there behaviors that an AI could look out for to understand when trust and distrust may be occurring? So we constructed 2 different versions of the system. One was the competent version, in which all the articles that were recommended had a high density of relevant keywords within the articles. And then we created a second one, which had very low presence of keywords related to the PIR within the articles. As users interacted with both of these versions of the system, a lot of behaviors in the background were automatically collected. Those included when users hovered over recommendations, chose to read an article in full, turn on or off assistive highlighting that was within the system, accepting a recommendation by providing a thumbs up, rejecting a recommendation by providing a thumbs down, or choosing to ignore those. So we had 6 different users take on the role of an intelligence analyst, and throughout the rest of the presentation, the prompt that users were given was, what is the projected growth rate of personal IoT devices in the US, and are there large-scale techniques to protect IoT devices within the US from global adversaries? The reason we had landed on this particular topic is that when we talk about collaborative decision-making, we wanted to provide users with a topic that most users would likely be unfamiliar with. When we talk about IoT devices as well as cybersecurity techniques, the common user is probably not an expert in those areas, and it's also likely that they could not fully answer this question with only one article. So we needed to provide them with an opportunity where they would have to put some level of faith into their AI teammate. This graphic shows a user flow of basically how people went through the task. They received a pre-survey and then reviewed 72 articles in either the competent or the incompetent condition, as these were counterbalanced, and then went through the second condition as well, and then completed a post-survey. After every 24 articles, we asked them a short trust survey to get an idea of what their trust levels were at that time. So going into some of those results, on the right-hand side, you can see a line graph that shows their trust and how that changed over time. Starting with the higher green line that has these circle nodes, we can see that through the competent condition for those users who started with that condition, that their trust remained pretty high over those first 72 articles. Then as they switched over to the incompetent version of the system, we can see that trust starts to fall until it stagnates over the 48th article and then remains flat. The interesting pattern is with the other group that started with the incompetent Alfred. We can see more of a sporadic pattern of trust in the incompetent condition as users were trying to get an understanding of what the system was really trying to do. Although in this series of tests, what we did was force the system to be incompetent. If a trainee were given a new tool and was unsure what the tool was actually responsible for, what we might see is a similar pattern of trust here. So we can see that kind of sporadic path, and then once they moved into the competent condition, we can see that trust then grew, but required going through the rest of the articles until it built up to the same level as those who immediately started with a competent system. So what's one of the takeaways here is that starting off with a system that it can be perceived as incompetent can take quite a bit of interactions until it reaches the same level of trust as those that kickstart with a good user experience. Next, we asked users qualitatively and looking at some of the data that was collected objectively, what were some of the actions that they took? So what you can see highlighted in the dark blue are actions that were exclusive to a particular condition. So in the incompetent condition, what we commonly found was that users were obviously more likely to reject articles. Over time, they were more likely to start skipping recommendations instead of diving into those as they weren't finding it high value, and removed other assistive highlighting from the system. When we look over at the competent condition, what we saw was that users were willing to accept more articles based off the title alone, and they were also more likely to open up an article and read the article in full. What we see as a common between these two conditions is that users were likely to start making decisions at the face value as they got more experience. In the incompetent condition, they were more likely to stop investigative behaviors and start skipping over those decisions. Whereas in the competent condition, they were more likely to take faith in the system and start accepting recommendations at the face value. Then we also asked users to rate how competent they felt the system was related to the 5 aspects of analytical rigor, which include aspects like providing a diverse set of resources, verifying details about accuracy of sources, as well as understanding the stance that sources take. Within this graph, we can see that the gray blob is the incompetent condition. We can see that that's smaller, which means that users rated that as lower, whereas the bluer, larger blob indicates a higher rating on all 5 of those dimensions. The biggest difference being assessing the relevancy of the recommended articles, which is kind of anticipated since that's the thing that we manipulated. And what we can see a little bit smaller is verifying the details of the validity and the accuracy of the sources, which is something that the system currently did not provide insight to the user about. So when we think about using these types of elements within other domains, there's similar interactions and similar factors that could be considered. So whenever someone is out shopping for a car, some users may prioritize gas mileage and safety, whereas other users may prioritize features and the color of the car. And so what we're able to do within here is extract some of those features in the intelligence analyst domain, but in joint all-domain command and control, there could be similarly extracted features that users are considering if they're in a C2 operator or in other domains such as that. And I'll get more into those details as we go along. So now that we had a good idea of what kind of behaviors could be used and the kinds of factors that users consider, we partnered with Carnegie Mellon University's Dynamic Decision-Making Lab in order to build a cognitive model of the user using their instance-based learning theory. What this did is looked at some previous decisions that they've made and then predict the likelihood that someone would accept or reject the next recommendation. To explain this in a little bit more detail, if a user had accepted an article that had certain keywords and it was written by a certain source and accepted that recommendation, the model would predict a similar article that had similar keywords and was by the same source, the user would be likely to accept that article as well. So building in this model afforded us a couple of different functionalities. One is that if the model predicted that they would reject a recommendation and the user rejected that, that would not be a high value time for us to query the user on why they made particular decisions. If I'm having a conversation with someone as a human, I may look for other human-related cues that we're currently having a shared mental model. I may look for head nods, you may start to finish my sentences, and your responses are making sense or in line with the conversation. However, if I'm having a conversation with another person and I see their brow starts to furrow, their responses aren't making a lot of sense, I may pause and say, hey, hold up, are we on the same page? And we'll work to make sure that our mental models realign. So what this approach allowed us to do is that if the model had predicted that they would accept an article and ultimately they rejected it, it would be an opportunity to allow us to intervene. So we chose to build in a couple of different intervention methods. The image on the left was the version that I showed you previously, the tell us why. So some of those examples on that image there are, I found the content irrelevant, I found the content untimely. So users could pick the different factors that we talked about at the beginning of the presentation, and those would get sent back to the cognitive model, and the weights of those factors would be changed. So not only can we start to individualize the representation of the human, but we can also understand as search strategies change. When we consider intelligence analysis and even the missions, these change over time. And what's most important to us, it also changes over time. One may say that we could ask people to rate their factors at the beginning before they go through any task, but often these change as the mission changes. So we're able to ensure that the AI is getting the most representative picture of the human as the mission changes. But we also don't want a boy-cried wolf scenario where we end up intervening too often. So we're only doing it when it makes the greatest value and the most sense for the user. And then lastly, we expanded the keyword search over on the right so that users could actually select those keywords, and then it would dynamically change the recommendations from the additions of those. So this allowed us a two-prong approach. The AI could align itself to the human goals, and the human could help the AI align the AI to what it was trying to get as well. And then lastly, I had mentioned that one of our findings from the trust curves is that kickstarting trust is a useful benefit to ensure that it remains high. So one of the things that we had built in was what we call a test set. Very similarly to when you set up a smart TV, asks you to pick some genres of movies so that it can start to give you personalized ads. In the literature, we find that kickstarting and co-learning with different AIs can be a trust-building tactic in and of itself. So the system prompts the user to accept 3 articles and reject 3 articles. So this allowed not only the cognitive model to get a little bit of each kind of decision so that the model could be more accurate right from the get-go, but also instill some trust right at the beginning for the user. So all of these features set us up to be able to conduct some follow-on tests, which we have done since the submission of this presentation, but I do want to cover some of the takeaways from the approach that we used. We believe that this kind of approach could be extended to multiple different kinds of decision-making scenarios. We all have factors that we consider, especially in a lot of command and control situations and other domains. We're working at computer stations, reviewing different pieces of information and looking at recommendations from those AI, so those web-based behavioral interactions can be leveraged. From some of these activities, what we discovered were that people adopt different decision-making priority or approaches with varying levels of importance. And one of the key aspects is using a dynamic approach so that we can improve the interactions with that AI-enabled system. Next is that tailor recommendations have to consider the user goals and also within the specific moment as those change over time. And next, that system transparency will drive users' mental models and the ability to capture behaviors. So by using that same approach, we can offer those key points for the AI to explain some of its reasoning as well. Lastly, we ensured that we tried to approach a naturalistic approach. As a lot of these operators, we won't be able to constantly train or explain some of the reasons of why AI that behaves the way that it does. Our tests were all conducted where users were completing this on their own computers without us in the loop, so that allowed all of those interactions to be similar to the operational field. Some future work that we have planned is to refine the intervention thresholds to intervene at the right time. So what we see is again, like I was saying, we want to avoid a boy cried wolf scenario. So how often is often enough to where an AI could work with different teammates to calibrate its own mental model. And secondly, extending this same kind of concept to a training domain. While this is more of an operational sense, we want to tie it over to training where we can take and build a cognitive model of an expert analyst and then use that to predict whether or not someone should accept particular recommendations from an AI. And when they don't, use those as an intelligent tutoring application. We also hope to explore a few different other aspects, including trust dampening techniques, as most of these were trust building techniques, examining metrics such as how much time they spent reviewing an article or the percentage of the article reviewed, and also exploring translucency over system transparency. We could present recommendation calculations to the user, but those may not be necessarily meaningful. And we could present all this data to the user, but then we also then get into an information overload. So how can we present insights into the AI's reasoning at the right times as well? So I want to take the time to thank you for attending this presentation, and I'll take questions if you guys have any at this time. Yeah, so like I said, we conducted our second test after the submission of this paper, and so what we saw is there were some users who actually never got any interactions, and I don't consider that necessarily a bad thing. It meant that they were getting what they needed out of the system, and when we looked at their trust ratings afterwards, it remained high throughout the whole task. What we saw was that users who were tending to be very inactive on the system and had kind of middle-level trust. When the system intervened, we saw then, after a few articles, that trust start to rise. So approaching it in this way ensured that the users who are working well with the AI are not interrupted and they can focus on the mission. But those where we're starting to see that they're not taking those certain behaviors that they should to ensure a good human-AI team, that they were getting the interventions and then saw the trust build after that. Yes.
You're using past information to help predict future information, whether or not they accept the article. How was that done? Was that done using like an AI clustering? Was it done regression? How did you perform that past to future?
Yeah, so that was using our partner's IBL model. So that's a version of ACTAR, so it's a cognitive model representation. So that looks at basically the value of all of the different factors and weights those and say this is much more likely that they'll accept it. We definitely could incorporate more AI-related approaches. The reason we had used this one is that instance-based learning can learn off of only a few interactions from the user. So we didn't need to generate a large data set for it to already start making predictions. And then we've played around with if it said that there was a 70% chance they would accept it and a 50% chance they would reject it, how big does that gap need to be for an intervention to be justified? Thank you.
All right, thanks again. As a reminder, please provide feedback using the survey via the Itsec app on your mobile device. Go to the program, select the session, and then the thumbs up sign in the upper right. Thanks again for coming today.